Thank you for your interest in the wireless I/O system, the easiest way from point A to B and back. In this training video, you will learn how to install and use the wireless system. Warning: ensure the installation of the system meets applicable state and national electrical code requirements. The installation of the system should only be performed by a qualified installer or a factory representative. Warning: to prevent ignition of flammable or combustible atmospheres, disconnect power before servicing. For our demo, here are the items that were used. 2 35mm DIN rail racks, 2 9 to 30 volt power supplies to power up our radio stations, a technician screwdriver, wires 28 to 12 gauge, a wireless system radio kit that includes 2 radio modules, 2 data rails, 4 end terminal brackets, and 2 data rail covers, and a USB to mini USB cable. The system requires 2 sets of antennas and SMA to N cables that are sold separately, a pair of digital I/O modules, 0 to 10 volt modules, and or 4 to 20 milliamp modules. To take advantage of additional system features, the advanced user interface is also required that is available on the website, and a PC. Warning: aside from learning how to use the system, the actual installation method of selecting the location, outer enclosure, antenna setup, and power management must be determined solely by the user. Let's now put the system together. Go ahead and take a data rail with the arrow label pointing up and attach it onto a 35mm DIN rail. Gently press and snap on the 4 corner clips into place to secure it to the DIN rail. As a good practice, build the system from left to right without leaving any gap between components. Now let's take an end terminal bracket and attach it to the system. First, hook the metal end of the bracket to DIN rail and then snap the other end onto DIN rail into place. Be sure to position the bracket far left of the data rail, where metal blades meet the plastic. Now, attach a radio module to the data rail. Place it next to the bracket without any gap. Now, connect an antenna. The radio module is equipped with an SMA female connector. For outdoor installation, place a lightning arrestor between antenna and radio module connection. Now attach a digital module and set the ID to 0. Then attach a 4 to 20 milliamp module and set the ID to 1. Then attach a 0 to 10 volt module and set the ID to 2. The wireless system can support up to 16 pairs of modules in any combination. The only exception to the rule is when using the internal loop power on 4 to 20 milliamp modules. In that case, the system will support up to 5 pairs of 4 to 20 milliamp modules. Once you are done attaching I/O modules, attach another end terminal bracket right next to the last module. Cover any unused slots with the supplied data rail cover. Simply snap off extra pieces and store for future use. Once you are finished putting the first station together, then assemble the other station by repeating the same exact steps. To remove or rearrange the system, here's how to remove the components from a DIN rail. End terminal bracket can be removed from DIN rail by inserting the tip of a flathead screwdriver into the removal slot. Control the direction with the screwdriver handle to pull the latch away from the DIN rail for safe removal. I/O modules can be removed from the DIN rail by inserting the tip of a flathead screwdriver into the removal slot located on the metal clip. Lift up on the screwdriver handle to pull the clip away from the DIN rail for safe removal. To remove the data rail, gently separate the 4 corner clips from the DIN rail by hand. When setting up and installing antennas, avoid walls, tall buildings, trees, and other solid obstructions for improving RF signal quality. Having a clear line of sight between antennas is ideal for best RF signal quality. Use appropriate antenna and high-quality antenna cables with the WiO system for achieving best performance. After the entire system is installed, verify the RF LED on the radio module is green, which serves as an indication for good RF traffic. Advanced. Run RSSI test. Utilize the WiO system's advanced user interface to evaluate received signal strength. In general, achieving above -85 dBm is recommended for signal quality. In an environment with low interference, 90 to 100% packet throughput can be achieved at lower levels, even as low as -100 dBm. Here's a quick digest of the signal chain using the digital module as an example. On station A, the input X, which can be input 1, will be transmitted to output 1 on station B. On station B, the input Y, which can be input 4, will be transmitted to output 4 on station A. Here is a snapshot of the radio module. The P1 terminal is for wiring an NPN digital output to alert when there is an I/O link failure. This can be caused by mismatch of I/O modules or when there is a damage to any of the communication components like data rail. P2 terminal is for wiring an NPN digital output to alert when there is an RF link failure. The default 10-second RF timeout will trigger this output. This RF timeout interval can be adjusted using the advanced user interface. Again, both outputs can be used for reporting a failed condition to a SCADA system. With the turbo transmit button, you can change the default transmit interval of 1 second to a faster transmit speed. The turbo speed is dependent upon the number of modules connected to a system. Press and hold the button for at least 1 second on either radio modules to activate the turbo mode. Simply press and hold the button again to return back to 1 second default transmission. Please take a moment to review the speed chart. The mini USB port is for connecting the system to a PC using the advanced user interface and for updating the firmware. The left LED is for RF traffic indication. Green is good traffic and also shows the rate of transmission. The yellow LED indicates RF link failure. The right LED is for I/O traffic. Green indicates that modules are detected. The red LED indicates I/O link failure. The P3 terminal is for wiring an external fuse if the internal fuse is damaged. Use a 3-amp fuse only for replacement. The P4 terminal is for power. The radio module accepts 9 to 30 volt DC and is reverse polarity protected. As another safety feature, you can wire in a dry contact switch for manual failsafe function. This function will manually override the system into a failsafe state for all outputs. To do this, use the available common terminal 10 or 12 and terminal 8 to wire up the switch. Here is a quick snapshot of the digital module, model BM-D100-144. This module provides 2500 volt field isolation. The P1 terminal supports wiring of input 1 and 2 with a shared common terminal. The P2 terminal supports wiring of input 3 and 4 with a shared common terminal. The green LEDs are line-driven input indicators. The 16-position ID switch is used for matching ID. Each pair must be set to its own unique ID. The red LEDs are logic-driven output indicators. The P3 terminal supports wiring of output 1 and 2. The P4 terminal supports wiring of output 3 and 4. The dip switches on the side of the module controls the outputs under fail-safe conditions. The fail-safe switch is on the disabled side. The output will simply report last known value. When the switch is enabled, the output can be selected for on or off. Here is a quick snapshot of the 4020 mA module, model BM-A420-122. This module provides 2500 volt field isolation. The P1 terminal supports wiring of input 1. The P2 terminal supports wiring of input 2. The inputs can be selected for internal or external loop power using the dip switches located on the side of the module. 16-position ID switch is located in the middle. The P3 terminal supports wiring of output 1. The P4 terminal supports wiring of output 2. Here is a quick snapshot of the 0 to 10 volt module, model BM-A010-122. This module provides 2500 volt field isolation. The P1 terminal supports wiring of input 1. The P2 terminal supports wiring of input 2. 16-position ID switch is located in the middle. The P3 terminal supports wiring of output 1. The P4 terminal supports wiring of output 2. Here is a live demonstration of the WIO system. Let's go ahead and power up the system and go over the radio module functions. During power up, the radio module will automatically detect the I/O modules and link the wireless connectivity. If the radio module detects mismatching of any I/O pairing, the right LED will turn red. You can also utilize the I/O link fail discrete output to report the status to a SCADA system. Once the issue is corrected, the green LED will indicate that the I/O traffic is operating normally. When I/O link failure occurs due to I/O mismatch, the module that is still left on the system will be put to fail-safe output mode. So while all the other functioning modules are working properly, just the mismatched modules will be failed over. If power or radio connection is ever lost for more than 10 seconds, the RF link fail will trigger and the left LED will turn yellow. You can also use the RF link fail discrete output to report the status to a SCADA system. Additionally, under this fail-safe state, the user can define how to fail over any output to a safe condition, which will be covered shortly. When the RF link is reconnected, the system will return back to normal state. With the turbo transmit button, you can manually shorten the transmit interval from default 1 second. Press and hold the button for at least 1 second on either radio modules to activate the turbo mode. Simply press and hold the button again to return back to 1 second default transmission. Turbo transmit is based on the number of I/O modules. With the mini USB port, you can connect a PC to it and utilize the WIO system's advanced user interface. The software is available for download on the website, and we will cover the UI features later as well. Now, let's cover the digital I/O module. The radio station A's discrete input 1 is connected to station B's discrete output 1. So when the input is turned on, you will see the output turn on as well. Again, the bidirectional communication allows the signal to be transmitted from station B to A. The fail-safe output can be controlled using the dip switches. For this demo, we have activated output 1 and 2. If not active, the last known value will be outputted. So when the failsafe state is active, outputs 1 and 2 LEDs will be illuminated. When the RF link is reconnected, the outputs will return to reporting the last known value. Now let's cover the 4 to 20 mA I/O module. The 4 to 20 mA input 1 on station A is outputted to station B's 4 to 20 mA output 1. So as the input value changes, we can see the output value change instantly. When the RF link fails, the output will go to 4 mA. With the advanced user interface, the failsafe output value can be preset to a specific value instead of 4 mA. Now let's cover the 0 to 10 volt I/O module. The 0 to 10 volt input 1 on station B is outputted to station A's 0 to 10 volt output 1. So as the input value changes, we can see the output value change instantly. When the RF link fails, the output will go to 0 volts. With the advanced user interface, the failsafe output value can be preset to a specific value instead of 0 volts. Now, let's download the latest version of the advanced user interface. Click on the product. Then under Downloads, click on Advanced User Interface to start the download process. Once downloaded, go ahead and install the software on a PC. Then connect the USB plug on the supplied USB to mini USB cable and connect it to an available USB port on your computer. Then, connect the mini USB plug into the radio module's mini USB port. Make sure the radio module is powered on. Once the system is connected to the UI, the WIO logo on the background will glow orange. By clicking on the WIO logo, you can view the software version and the radio module firmware version. You can also easily zoom in or zoom out to have a better view of the screen and reduce eye strain. Here, you can also instantly check the RSSI for testing the quality of the RF signal. Local RSSI is the strength of incoming signal, and remote RSSI is the strength of the outgoing signal. In general, achieving above -85 dBm is recommended for signal quality. In an environment with low interference, 90 to 100% packet throughput can be achieved at lower levels, even as low as -100 dBm. The outgoing signal strength can be controlled using the power transmit adjuster. The failsafe timeout can be adjusted as well, up to 30 seconds. After any changes are made using the UI, you must press the Apply button for the changes to be updated onto the devices. Do not disconnect power or the USB cable while updating. On the I/O table at the bottom, it lists the I/O modules connected to the system. Each module is color-coded for quick reference. Red for digital, blue for 4 to 20 mA, and green for 0 to 10 volt. Let's click on the digital I/O module. Once the window is open, the selected module will have a blue highlight indication. This window shows the status of inputs and outputs. It also shows the failsafe status of each output that is controlled by the dip switches. You can force an output by activating the F button. Then you can turn the output on or off. When the force output is active, the module will have a yellow border for indication. Now, let's click on the 4 to 20 milliamp module. This window also shows the input and output status of the module. You can also force an output using the F button and moving the needle to a desired position. Using the failsafe feature, you can also preset the failsafe output value when RF communication is lost using the blue triangle needle. You must click the Apply button for the change to take into effect. Now, let's click on the 0 to 10 volt module. This window also shows the input and output status of the module. You can also force an output using the F button and moving the needle to the desired position. Using the failsafe feature, you can also preset the failsafe output value when RF connection is lost using the blue triangle needle. You must click the Apply button for the change to take into effect. While you are connected to the UI, if the RF failure occurs, the RF fail indicator will be activated left of the screen. When I/O link failure occurs, the I/O link failure indicator will be active to the right of the screen and specifies which module is mismatched. Any forced outputs will be automatically deactivated when you close the user interface or disconnect the mini USB plug from the radio module. This completes the training. We sincerely thank you for your time.